So we're going to continue topic 2.2 and 2.3, and sometimes the instructions to do this exact same thing we did in the last example are going to say find the derivative by the limit process. So they're being specific about this. And actually, when I'm going to assess you on this, I'm just going to have you do this one type of problem on that assessment. And we will talk a little bit about what that's going to look like here, probably on Monday. So we're going to find I'm going to write out my derivative formula. So f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So I know that this means if we're going to plug in x plus h and x anytime I see an x in this function. So I have the limit as h approaches 0 of, I'm going to have something cubed plus 2 times something minus parentheses something cubed plus 2 times something. So I'm just setting up my skeleton of my problem. Now I'm going to substitute in. The first sets of parentheses get x plus h's, and the second sets just get x's. So they really don't look any different than the original function in that back piece. All right, so here comes the fun part. We need to cube this guy right here. So that means I have to do x plus h times x plus h times x plus h. So I am going to FOIL the first part. So x times x is x squared. X times h is xh, but I have two of those, so plus 2xh. And then h times h is h squared. Now I need to multiply that out. I'm going to get out the box to multiply that out. I know it's been a while since we've seen the box. And this just helps keep my work organized so I don't miss any of the parts. So x times x squared is x cubed. X times 2xh would be 2x squared h. X times h squared is xh squared. H times x squared would be x squared h. H times 2x is 2xh squared, and h times h squared is h cubed. So I am going to write that in. So the limit as h approaches 0 of, I'm going to put that in place of what we had there. So we're going to put in I'm going to simplify it as we go, x cubed. I just turned it orange, it should have been red. And then these guys are like terms, so I have plus 3x squared h. These ones are like terms, so this would be plus 3xh squared, and then the plus h cubed. Now we're going to go ahead and just distribute this 2 into here. So plus 2x plus 2h. And then we are going to simplify this back piece, which really the only thing I can do is distribute in that negative. So negative x squared minus 2x. And remember, as we were doing these, the goal was to get rid of all of your terms that don't have an x in it, and then get it down to where you can factor something out and cancel with the h. So let's see what we have left here. I'm seeing an x cubed and a negative x cubed. I'm seeing a positive 2x and a negative 2x. So it looks like I've got all of that out. I am going to just rewrite this out just to see where we're at. So the limit as h approaches 0 of 3x squared h plus 3x h squared plus h cubed plus 2h all over h. So it does look like I have an h in each term, so I'm ready to factor out the h. The limit as h approaches 0 of h times 3x squared plus 3x plus h squared, I should have had an h here, plus 3xh, because I had 2, I only could take out 1. I'm left with h squared there plus 2 all over h. I'm going to cancel my h's. So now I have the limit as h approaches 0 of 3x squared plus 3xh plus h squared plus 2. So I'm now going to substitute in 0 anytime I have an h. I'm now down to the direct substitution method. So 3x squared plus 3x times 0 plus 0 squared plus 2. Well, these two terms would zero out, and our final answer would be that the derivative is 3x squared plus 2.